Okay, so when you're building any modern application, you've always got sensitive data to deal with, right? We're talking API keys, database passwords, all that good stuff. And rule number one is always, get that stuff out of your code. But where do you put it? Today, we are going to dive into Kubernetes' native solution for this, and we're going to uncover a really common and pretty dangerous misunderstanding.
So here's our game plan. We'll kick things off with the problem itself, then look at the solution Kubernetes seems to hand us on a silver platter. After that, we're going to peel back the curtain and see what's really going on. Then we'll get into the real-world risks and, most importantly, walk through the pro-level strategies to actually lock your sensitive data down for good.
All right, so rule number one in any sane development process is separating your configuration from your application code. Now, for the non-sensitive stuff, like a theme color or a public URL, Kubernetes gives us config maps. They work great for that, but what about the stuff you really need to protect?
Yeah, just throwing these into a plain text config map is a huge no-no. I mean, think about it. If that file accidentally gets committed to a Git repo, or if its values get printed out in some container logs, that's it. Game over. Your sensitive data is just out there. We need something better, something actually built for, well, secrets.
And this is where the Kubernetes secret object steps into the spotlight. You look at the name, you read the docs, and it seems like the perfect, tailor-made solution. It's an object specifically designed to hold and manage all that sensitive info, keeping it nice and separate from your pods.
And the workflow feels so easy, it's almost too good to be true. You run one little kube control command to create your secret, you point to it in your YAML file, and boom. Your app spins up with the data it needs right there in an environment variable. It feels clean, it feels simple, and it definitely feels secure. But is it?
Okay, this is where things get really interesting. We've created our secret, it's living in the cluster, everything seems fine, but what does that secret actually look like under the hood? Let's pop it open and take a look. So if you actually go and inspect the manifest for the secret you just made, you'll see the value isn't your password in plain text. Instead, it's this long, jumbled up string of characters. And honestly, at first glance, this looks great. You think, awesome, it's encrypted or hashed or something. And a lot of people just stop right there, assuming they're totally safe. Check this out. This string right here is the actual value that Kubernetes stored for our password, which was skh_approach123. As you can see, it definitely doesn't look like our original password. So this leads to the million-dollar question, doesn't it? You see that scrambled string, and your brain just automatically goes, okay, we're good, it's encrypted. But is that what's really happening here?
And here's the big reveal. That string isn't encrypted at all. It's just base 64 encoded. It's a standard, completely reversible format. Anyone, and I mean anyone who gets their hands on this string, can run one simple command and instantly get your original plain text secret right back. Not so secret anymore, huh?
This right here is probably the most important thing to get straight. Encoding is not encryption. Encoding is about changing data so it can be safely transmitted. It's like putting a letter in a translucent envelope. Sure, it's in something, but anyone can still see what's inside. Encryption, that's a locked safe. Need a specific key to open it. And by default, Kubernetes secrets are just using that translucent envelope. Okay, so we've burst the bubble. We know secrets are just encoded, not actually encrypted. So what? What does this actually mean for you in the real world? Where are the actual dangers? Well, there are two huge attack vectors here. First, and this happens all the time, a developer has a long day, they're tired, and bam, they accidentally commit a secret manifest file into a Git repository. Now, anyone with access to that repo has your secret. The second, and way more serious risk, is that all these secrets are stored in your cluster's etcd database. If an attacker gets access to etcd, they can just read all the secrets, run that simple decode command, and they own everything.
All right, so the default setup is clearly not good enough. But don't worry, the good news is there are some really powerful professional ways to fix this. Let's talk about how to move from this weak baseline to a truly rock-solid security posture. Let's do this like the pros.
The best way to think about it is like leveling up your security game. The good step, the absolute bare minimum you should be doing, is enabling encryption at rest for your etcd database. Better is when you layer on strict role-based access control, or RBAC, to tightly control who can even read secret objects in the first place. But the best approach, the real gold standard, is to use an external system that's literally built for managing secrets. So let's quickly break down these top-tier options. Encryption at rest is your baseline. It protects the data if someone steals a backup of your etcd drive.
A KMS provider is a huge step up. This offloads the actual encryption work to a super secure external service like AWS KMS. The key to the kingdom is never even inside your cluster. And for the ultimate control, you have external managers like HashiCorp Vault. These tools handle the entire secret lifecycle, rotation, dynamic secrets, the whole shebang, completely outside of Kubernetes.
And by moving up to these professional-grade solutions, especially something like a KMS provider or an external manager, you directly shut down those two primary risks we talked about earlier, that accidental exposure in Git and a devastating breach of your etcd database.
So after all that, what is the single most important thing you need to remember when you're thinking about your own Kubernetes security strategy?
It's this right here. Default Kubernetes secrets provide obscurity, not security. All they do is stop someone from casually looking over your shoulder. They offer zero real protection from a real attacker. True security isn't something that just happens. You have to be intentional. You have to actively build it.
And that really just leaves us with one last and pretty important question. So go ahead, take a hard look at your own clusters, your own workflows. Now that you know the critical difference between being merely encoded and being truly encrypted, are your secrets actually secret